We're going to wrap up our unit on meteorology with looking at climate. Climate and weather are very different things, although they go hand in hand. Weather are the conditions at a specific time. Climate looks at long range, average weather conditions over a great period of time. One of the things we use to interpret weather and climate are weather maps. You can see the idealized weather map below, showing you the fronts where the air masses meet, the general high and low, where you can get a good idea of wind direction and the weather as far as precipitation goes. So these weather maps are put together by individual stations sending station models. This one happens to be done by NOAA, the federal branch, looking at the atmosphere. So meteorologists use weather maps to help them see the patterns in weather. Isobars connect equal areas of pressure. We know that iso lines connect things. We also see isotherms and other iso lines used in weather maps. So in this map, you can see individual stations report pressure. A meteorologist takes this map and draws the iso lines showing areas of high and low. We know cyclonic and anticyclonic flow, so that can be added. And then the fronts are added where you can see the pressure changes. This is how we look at weather and predict weather over the course of a day or two, knowing the information and the patterns that weather generally displays. Surface temperatures can be interpreted the same way. Here are surface temperatures sent in. Meteorologists interpret them iso lines, and you can interpret where the centers of high and low and where your fronts are located by temperature differences. Altogether, you get a synoptic map, which is a synopsis of all the weather conditions after all of the individual maps are. And the synoptic map shows you these station models from reporting. You can see the cloud symbols are there. You can see the precipitation symbols are there. And this is the data that a meteorologist gets. Now, most TV meteorologists aren't necessarily trained in meteorology as their undergrad degree. They have to get certified and they take courses, but usually they undergrad in something else, communications or news broadcasting or journalism, something along those lines. When an opportunity opens up in the meteorology department, they have to take it, and then their career takes shape. So climate is the average weather over a 30-year time period. Weather is short-term. Some earth scientists use the Köppen climate classification system, developed in 1900. It takes into account a lot of factors, the climate zones like tropical, subtropical, the soil vegetation, and other things. And the system uses 5 climate types based on precipitation, temperature, and vegetation. Here are your climate types. You have tropical or type A climate. You can see that's found in the equatorial regions. You have dry. Notice the desert-like conditions. Those fall in the horse latitudes, like I mentioned, that high pressure belt. So very dry. Dry climate is most of the world's land. You can see the Sahara there. You can see the Australian outback. You can see the desert of the American Southwest. So dry climate takes up most of the land surface. Then you have your temperate zones. Then you have your cold, type D, cold. Cold is the second largest. You can see a lot of cold. And then polar climate, where you have your ice cap or your permafrost. So your moist tropical climates, type A, no winters, near the equator, a lot of rainfall. The dry climates, arid, desert, semi-arid. That's our grassland, semi-arid. Steppe, STEPPE. That's the dry climates. Type C, the mid-latitude climates. They're found in humid subtropical climates. A lot of North America has this climate. D are the continental climates. E are the cold climates. You have tundra or ice cap. We're going to wrap this climate and unit up with the human impact on global warming because it's always in the news. We do have natural climate change, but humans are responsible for climate change mostly since 1900. The Industrial Revolution, we started to add these aerosols and carbon dioxide and oxides into the atmosphere, and it's been building up, and then we crossed a tipping point to where the global weather changed, started to warm, and our sea levels have started to rise. You can see that most of our energy comes from fossil fuels, and that all that leads to, and even renewable energy, when you're talking biomass, you're burning it, that all leads to oxides being released into the atmosphere. So the temperatures have been rising. We project a increase, and now that's a big range, 1.4 to 5.8, but we project it to keep rising, and carbon dioxide is the number one, and then methane, nitrous oxide, and chlorofluorocarbons follow behind. You can see here's the temperature data and how we've been rising steadily. In conclusion, the human impact, the gases we put in the atmosphere trap outgoing waves and act like a blanket. So one of the consequences of global warming is sea level rise. Another consequence would be our water resources and the productivity of agriculture. And then the third would be weather patterns changing, increased hurricanes, increased cyclonic storms, and more drought-like conditions.